All right, hello everyone. This is John, and today I'll be covering part 3 of longitudinal multi-level modeling in R. I'll quickly go back to the outline. So in the first two videos, we sort of did a step-by-step process on building your multi-level model in R. First video was putting together the unconditional means model, and the last video, video 2, was putting together the unconditional growth model. Video 1 was just setting up the intercept and the grand mean, and then video 2 was setting up the appropriate slope that would fit the model. And now finally in this last video, video 3, we'll be doing the full model or the conditional growth model, which will include all the predictors from our research question. So just to quickly recap, first video, just as I was saying previously, we put together the unconditional means model, which was setting up the intercept, which we found out was significant from 0. At this point, we're only looking at our dependent variable, which was job performance. There is no predictors or measures of time within the model just yet. And then in the last video, we did the unconditional growth model, where now we, from the intercept, created a slope, either fixed or random, using now a measure of time, which was how many days of training participants took part in, or employees, I should say. And what we found was, comparing the fixed or random slope, that a random slope was a good fit to the data based on the log-like values and deviance statistics. We found that it was improving the fit of the model. So now, of course, the last step now is to now include our predictors within this model, which is now what I've highlighted here, more of the independent variables of this study. So to quickly recap, the research team wants to determine how much a 4-session on-the-job training will improve employees' job-related task performance. The on-the-job training took place at 2 different job sites, and employees rated their satisfaction with their trainer and rated their overall job satisfaction as well. So in video 1, we only looked at the dependent variable, which was job performance. In video 2, we established a repeated measures to compare amongst job performance. And now in video 3, we're going to include these 3 predictors: job site, satisfaction with trainer, and overall job satisfaction, to see whether these would have any other role in predicting job performance as well. So the research question is very simple. Does job site, satisfaction with trainer, and overall job satisfaction impact the training and the job performance that employees took part in? Similar in the last video, we're going to create the model and then compare it to the last version of the model. So in video 2, where we compared the unconditional growth model with a fixed and random slope to the unconditional means model from video 1, in this video, we're going to compare the full model, which includes all the predictors, to the unconditional growth model with a random slope from video 2. There's no real purpose in comparing the full model to the unconditional growth model with a fixed slope, because we already ruled out it was not significant. It did not significantly differ from the unconditional means model and was not an appropriate fit to the data. So in this situation, we're just going to compare the full model, which we're going to put together momentarily, to the unconditional growth model with a random slope. So let's jump over to R. And of course, we're going to now start putting in our predictors into the model. So of course, make sure that data set is loaded, which mine is already done. It's in the global environment. And then have the NLME package available. I'm just going to run it to make sure it's available and ready. And now we're going to go right into building that full model, which is the conditional growth model. So it's going to be called Mod 4, and it's the newest version of the model. We have our dependent variable, which is job performance. We have days of training, which is also located here, because remember, it was a random we're using it as a random effect and random slope across individuals. And now we have our predictors in the model. We have job site, satisfaction with trainer, and job site by satisfaction with trainer. And finally, we have overall job satisfaction as well. You could see I've added plus signs between each one because I'm really only interested in looking at the main effects and interactions for certain variables. If you do not add these plus signs and you just add a star between each of your variables, so it'll be, for example, days of training, star job site, star satisfaction with trainer, star job satisfaction, you're going to get a lot of different interactions. And if you don't have hypotheses for these interactions, they're not really, it's not really an appropriate method to take. So that's why I've specifically added each main effect I'm interested in, which is, of course, job site and satisfaction with trainer and job satisfaction. Those are my main effects. And then I'm really just looking at the interaction between job site and satisfaction with trainer to see if that had any role to play as well. So that's really all that I'm going to look at within the full model. There's many other ways of combining the variables by adding a star between them, but for the purposes of this demonstration, that's not really, and the research question really, that's not what I'm going to do. So of course, everything else in the model is pretty much the same from the previous videos. All we're doing now is adding our predictors. So we can highlight this with summary and click run. And right away, you can see how much bigger and more detailed the model is becoming. One of the first things to look at is the log-like, and we can see it's dropped even more from our last model, which was model number 3, the unconditional growth model with a random slope. So when running deviant statistics, this is probably going to be significant. And then later we can also look at some other things. We can look at the intra-class correlation coefficient to see how much clustering is still apparent within the data. And then finally, and the more important thing really, is to look at these fixed effects. These fixed effects we have here. Let's begin with the interaction. We have job site with satisfaction with trainer, and it is significant. What's interesting here is that the value is negative, but it's really negative in the sense, which I'm going to show momentarily, based on how things are coded within your data. So for example, if I quickly go over to data 1, I have job site coded as 1 and the second job site coded as 2. Okay, it's important to keep this in mind when you start looking at the values for your fixed effects, because you might think that there's a negative relationship taking place here, but in all reality, what this negative value is saying is that there's a big difference between job site 1 and job site 2, and based on a fixed effect, one job site is obviously much higher than the other. And in this case, if it's negative, it's probably pointing to job site number 1 being substantially more, showing a higher rate of performance compared to job site number 2. And I'll actually show that really quickly in a plot before I start interpreting more of the other results. So I'm sort of skipping down below here to show an interaction plot. You don't need any library to run one of these. All I'm doing is comparing days of training across job site based on job performance. So I'll just quickly run this because I want to show why these negative values can occur. So as I was saying, job site 1 and job site 2, that's the way things are coded. But you can see this negative value, I just want to show it here, this negative value here, and although it's significant, all it is really suggesting is that job site 1 had a higher rate of performance compared to job site 2. That's literally all that value is saying. So it could be deceiving to think that there's a negative relationship taking place when all reality there isn't. It's just job site 1 is much higher than job site 2. So that is a good thing. We could see that there was an interaction, and based on our research question, we were able to discover that interaction. At this point, interpreting the other values, it's not as important because the interaction was there, but we can quickly look at some of the main effects now. Here's one to look at, was overall job satisfaction. Did overall job satisfaction have any role to play in how well people did within the training? The value is not significant, so it really had no effect, which is fine. And then, of course, the main effects for job site satisfaction with trainer are significant, which makes sense as the interaction itself is significant. And we can see here that days of training is significant as well, whereas in some of the previous models it wasn't significant, but now that we've added more predictors, we could see that level of significance has increased. Really, there should be some other tests done to make sure that there isn't some p-value inflation taking place here, but we could tell by just looking at some of the plots that over time there was a substantial change, and that having these predictors in the model, job site, satisfaction with trainer, is demonstrating a significant change based on the amount of training that took place over time. So that's not really a big surprise. So it's important, though, when you're trying to look at all these values, is to take the time to look at the plots to really just see that you're interpreting the numbers or these values the same way as the plots are depicting. So we could see with that first interaction plot that this negative value below was attached to job site number 1. But we can run another interaction plot here, this time looking at satisfaction with trainer based on job site to see how much that would differ. And here it is. So it's hard to see maybe on the side, but saying satisfaction with trainer based on job site, you can pretty much see here that over the 4 days of training, job site number 1 seemed to have more satisfaction with the trainer they were provided than job site number 2. Hence why perhaps there was not as much job performance, or wasn't at least demonstrated at job site number 2, something to take into account. But a library that I've been using and like to use is Lattice. I used it in the last video, and I'm going to demonstrate some more plotting here, just different methods on how you might want to try to interpret some of these plots, or at least have some visuals available to you when going through some of these results. So for example, I can click Run Lattice. We can do a simple XY plot where we have individuals, but we're going to color code them based on job site. So we can run that. And there we go. So in video number 2, where we saw an obvious decrease in some individuals and an obvious increase in others, we could see once it's color coded, job site number 2, which is that pinkish purple, is decreasing, whereas job site number 1 is increasing, which we saw from the interaction plots. And then there's just some other options here you can run as well. Just like the interaction plots above, these can be run for based on job site. So this is just same thing as the interaction plot above. We have job site 1, job site 2, or we can run it for satisfaction with trainer, just like I did above. And same thing, job site 1 and job site 2. One thing actually I did not include, which I should, was for the full models to look at these intervals. Okay, let's run these intervals really quickly to see what's going on. And this is where it's important to really be able to know how to understand confidence intervals, because based on that interaction that we had previously, job site and satisfaction with trainer, we can see that all the values are negative, meaning they're all lower than 0, or that baseline. Once again, some individuals might assume that this is a negative relationship taking place, but it's really depicted based on job site. So that's job site number 1. It's definitely more significant than job site number 2, and it's very well depicted there. Job satisfaction, as we noted earlier, it was not significant, and based on confidence intervals, it is not significant. And then of course job site 1, job site and satisfaction with trainer are significant as well. An important thing though to mention too is that when we look at days of training, the random effects are really high. There's huge confidence intervals between them, suggesting there's a lot of variability taking place here, and that is easily depicted within the plots that we saw. A lot of variability, definitely a lot of significance taking place here. So the next thing though I'd like to do is then really compare those deviance statistics. Let me just clear the space. In video number 2, we created the unconditional growth model with a random slope. I want to include that in my global environment here, so I'm just going to quickly run that. Let's clean that up. We don't really need it there. But in my global environment, I have now model 3 and model 4. Model 3 was from video 2. Model 4 is from this video. And now I'm going to run those deviance statistics like I did in video 2 to really compare them to see how much better the full model is in terms of fit compared to the last model. So I can run that here. And of course, it's significant. So that these predictors that I've included within this model, particularly job site and satisfaction with trainer, overall job satisfaction was not significant and wouldn't contribute much or if at all to this model. But we could see that it is significant here. And therefore, these things are predicting job performance. These do seem to be having some sort of impact within the data. I'm actually going to skip step 6, for a second and go to step 7. Once you've built your full model, probably more important than calculating intra-class correlation coefficients is really to calculate the proportion reduction. Really, how much variability is being explained between the two models, and really in this case model 3 and model 4. The unconditional growth model with a random slope and our full conditional growth model. So running these codes here, we're going to compare level 1, which is the days of training, the repeated measure to job performance. We're going to compare level 1 in both models to see how much that unexplained variance is being captured in the full model. And then for level 2, which is here, you can see it's 2-1, whereas above it's 1-1. So level 2 here, we're going to be comparing days of training plus all the predictors we're including in our model now to see how much of that unexplained variance is being captured within the full model as well. So let's quickly run this first step here, looking at level 1. So we have our values here. We can see that there is a proportion reduction taking place. But now we're going to use this formula here, something that you're just going to have to plug in with your own models to run, to see how much of the proportion reduction or unexplained variance is being captured in the full model. And you can see here that about 50% of that variance is now being captured with our predictors, or within the full model now, which is pretty good. But now it's really level 2 when we're going to have our predictors now in place that we're going to be able to see how much more variance is being explained. So let's run these now. And now run this specific formula, which once again you'll just have to include your own models in this formula to calculate proportion reduction. Run, and wow, 91%. So just by adding these predictors within the model, right away, we're accounting for 91% of that unexplained variance. That is what is being captured with these predictors. Quite substantial, very important. And this is good to know, to see how much your full model with all of its predictors is capturing that unexplained variance. One thing I wanted to do up above, which I sort of skipped, was looking at the intra-class correlation coefficients. Not really necessary once you have your full model and you can calculate that proportion reduction. But the reason I included it was just to show, really what I wanted to show here is that there might be certain predictors you have in your study, but it doesn't necessarily depict all the variance or clustering that could be taking place within your data. So for example, if I run these two, I'm going to run the first one for the unconditional growth model with a random slope, and then I'm going to run it for the full conditional model, which is mod 4. We're going to run them to see how much clustering is being explained in each, or how much is evident really in each. So as we saw in video 2, 79, so that means there's 79% of clustering taking place when we just have a random slope with no predictors. And by the time we add our predictors, which in the full model, it's now at 63%. The idea here is both of these are very high value still. Even for the full model, the amount of evident clustering that is taking place is still very high. Our proportion reduction, as highlighted here, is explaining a lot of that unexplained variance. But you could see, based on the predictors that we did use, that there's probably other information that could still be captured within such a study, and other things that researchers might want to take into consideration in future studies as well, especially with such a high amount of unexplained clustering still taking place within your data. But yeah, so that's pretty much all the steps taken to running a longitudinal multi-level model in R. As the results suggested, job site and satisfaction with trainer did impact job-related task performance during the 4th session on the job training, but overall job satisfaction was not a predictor of job-related task performance. So yeah, that's pretty much everything that needs to take place for running a simple 2-level longitudinal multi-level model in R. And thank you very much for watching.